Behind every semiconductor chip lies a marvel of engineering precision. Probe cards containing up to 200,000 individual probes, each the diameter of a human hair, carrying amps of current at hundreds of gigahertz. From testing today's AI processors to preparing for quantum computers that operate near absolute zero, FormFactor's innovations span from microscopic to the revolutionary. Let's explore the cutting edge technologies that make modern chip testing possible. Mike, let's look at a couple of specific ways that FormFactor has been working on, product innovation. And the first one I want to talk about a little bit is probe technologies. What's going on there?
Well, the probe, as you might imagine, is the heart of a probe card. Now, a probe card is up to 150 or 200,000 of these individual probes. And we use a proprietary technology that was invented by FormFactor called MEMS technology to build these probes. They're remarkable structures. When you look at them, as I've said before, they're about the size of a human hair or the diameter of a human hair, carry amps of current at sometimes hundreds of gigahertz of frequency, very high test speeds. So remarkable little structures. And then we put them all together on these probe cards where each of the 100,000 probes has to be positioned within a few microns of its intended point so that it contacts the right place on the chip and work for millions of cycles. So, the advancements here are really about fundamental innovations in material science, in MEMS processing, in assembly techniques. We use very high speed robots that we've developed internally to place these probes in the right position. But all of it really is geared towards making a more capable interface for our customers, higher speeds, higher currents, higher power. And if we go back and think about the requirements for testing the GPUs and high bandwidth memory associated with Gen AI, all of these innovations are pointed at improving and accelerating that roadmap.
And there are so many areas that are evolving across the spectrum of things that you work on. Talk a little bit about photonic device testing.
Yeah. Well, photonics, particularly silicon photonics and its implementation in co-packaged optics is a really exciting area right now. You can think of our presence as being essentially building probe cards or probe systems that interface between testers and the device using light, using photons, using optics, instead of the electrical connections we do in most of the rest of our business. But as the industry moves from using electrical signals to using optical signals to transmit data back and forth in the data center, it's a natural extension for our business. And we've got a tremendous history of innovating in the silicon photonics area, collaborating with key customers in their labs over a decade ago to start to develop the fundamental core technology, and only now transitioning to full high volume production as silicon photonics and co-packaged optics starts to be adopted in industrial applications.
And then another area that you're quite excited about is the work around quantum computing and equipment testing there.
Quantum computing, another interesting extension for us. Our product portfolio there, really an extension of our probers and probe cards that are used in mainstream semiconductor devices. But of course, quantum devices need to be characterized and tested as well. The challenge there is most quantum processors need to run very close to absolute zero, colder than outer space. And so there's a whole unique set of challenges associated with making contact to a device, maintaining that contact, and connecting it to some sort of test equipment, not the least of which a challenge is not raising the temperature of it. So you need to make sure that you're almost processor while connecting to it so it can be tested. It's an area where, of all the things we've talked about today, probably a longer term opportunity for FormFactor. If we think about Gen AI, GPUs, and high bandwidth memory, that's here. That's today. We're shipping in volumes hundreds of millions of dollars of business annually for us. We talked about co-packaged optics. That's just reaching volume production. Think of it as a few $1 million of annual business for us, but hopefully growing to a significant level. Quantum computing, a brand new industry. And so if we think out 3 to 5 years when quantum computing has really reached industrial relevance for problems like drug discovery, problems like encryption and code breaking, we expect that business to grow as well. But part of our strategy is to be in on the ground floor. That's where we are today with testing quantum processors, just like we were a decade ago with testing HBM. And you ride these things from the lab through pilot production into the fab, and they grow into significant businesses for us and the overall industry.
Well, part of your role in sitting in the CEO chair is to be thinking out that long term and talk about sort of the next generation of technology coming down. And just talk about kind of what your own kind of personal vision is for form factors as it relates to being, maintaining this leadership position and helping to drive the innovation that will take this industry forward.
I mean, I think if you look at our fundamental mission, our fundamental reason for existence, it is to enable these applications across the semiconductor and broader electronics industry. Whether that's things we now take for granted, like mobile phones, we were early innovators and early suppliers in some of the first generation iPhones and continue to be a key part of that supply chain. Now, as we look at how we're enabling generative AI with probe cards and test systems for graphical processing units or GPUs and HBM, that's here today. And as we look down the road, continuing that mission and enabling things like silicon photonics and co-packaged optics, and then down the road even further, things like quantum computing. That's the fundamental mission of Form Factor. And the way we drive that is to stay very close to our customers, make sure we're having those longer range discussions with them while still staying focused on the present. But also, if I return back to the theme of collaboration, our collaborators also have a view of where the industry headed and some of the projects that we should be working on to make sure we have compelling products and systems of products that work for our customers, that solve our customers' test challenges when these technologies start to reach volume production.
Mike Slessor, CEO of Form Factor, all the chance to talk a little bit about your company and also the ever-changing dynamics of the industry in which to compete in.
Thanks for the opportunity, Paul. Enjoyed the conversation.
From enabling the first generation iPhones to powering today's AI revolution and preparing for tomorrow's quantum breakthroughs, Form Factor's mission remains constant, solving the industry's most complex test challenges before they reach critical mass. Through continuous innovation and strategic collaboration, they're not just keeping pace with the semiconductor industry, they're helping define where it goes next. As Mike Slessor reminds us, success comes from staying close to customers while keeping one eye firmly on the horizon. I'm Paul Swangard for Mission Central.